The radius, the radius of a curvature of a spherical mirror is given, which is 20 centimeter. Remember, it is a radius. 20 centimeter is the radius of a spherical mirror. What is its focal length? This is what we have to find. Try to understand this question. If you are getting clarity, then we can move. We can move towards the solution. Uh, what are those things that are given by the question? Just write all those things, all those given things in your process. Okay. So as you can see, radius is given, which is 20 centimeter. But remember, the radius of a curvature of a spherical mirror is given, which is 20 centimeter. R is 20 centimeter. We have to find its focal length, where R is 20 centimeter. Are you understanding? Do you have any kind of a doubt? Now tell me, what is the formula of calculating focal length of a spherical mirror? So of course we know that focal is a half of, or you can say 2 focal length will be equal to 1 radius. This is what we know. It's a concept. So here we have to find what? Question is saying find focal length. Okay. So radius is, this is a complete. Suppose half of this would be what? Just focal length. So can we say F is equal to R upon 2? This is what will be formula for calculating focal length, where R is a given. Yes. Now this formula is saying that F is a half of a radius. What is it telling you? It is telling that F is a half of radius. Okay. Now from this we will get focal length, which is coming 10 centimeter. Yes, this is 10. So 10 centimeter is a focal length. Okay, I hope you have understood. This was not too much difficult, brother, but yeah, we just started from scratch. Okay, so in the beginning we cannot we cannot jump on advanced question. Why? Because I don't want you feel nervous. Okay, feel confusion. Next question I am going to write. Yeah, it's an next question. Try to understand it. Are you getting clarity or not after reading this? So in this answer is a 16. But how will we bring this much answer? Let's read. Find the focal length of a convex. Focal length. Again, it is saying find focal length. As we saw in this question, it was also saying find focal length. Now let's see what's the difference between them. Find the focal length of a convex mirror. Mirror is given, which is convex. In this mirror was not given. In this mirror was aspherical. So it is convex mirror, which is a part of a spherical mirror. So find the focal length of a convex mirror. It is exercising, brother. It is emphasizing that a mirror is a convex. Okay. So what's the radius of a curvature is 32 centimeter. Whatever points are given by the equation, just write all those points in the process. So solve, let's solve. So R is given. R is a 32 centimeter. R is a 32 centimeter. Now same you can see here. How much? 16. Same process. Same. So F is equal to R upon 2. This is what is a formula to calculate a focal length. Okay, we cannot change it. From the concept we got this formula. So here, whatever value of R is given by the equation, just substitute that value. So R is a 32 upon 2. So 16 to the 32. So F is coming out as a 16 centimeter. What are you understanding? Focal length of radius 32 centimeter of convex mirror is how much? Is a 16 centimeter. Clear? Yeah. This is our answer. Just have a look, then I will erase it so that we can move towards the question. Now, I am going to write my question. Now it's a computer. I know I'm taking too much time just to write this question. But remember, it can take too much time. Not too much time. Read this question and try to understand what are you getting clarity. Here answer is V is equal to minus 30 centimeter. This is what we have answer. Now read this. A concave mirror. We have a concave mirror which was a concave mirror which was reflecting surface is inward surface is a reflecting surface. Okay. So what I'm saying, this is a mirror. Now this outward part is a coated area. This outward part is a painted area. This inward part is this inward surface is our reflecting surface, and this mirror is nothing but concave mirror. So a concave mirror produced 3 times magnified, 3 times, 1 time, then again 2 times, then again 3 times. 3 times magnified. It means it is a more large. Image, real image. Okay. So a concave mirror which is producing a real image and it's a very large, 3 times large. Okay. So we have real image, not virtual. Real image. So a real image of an object which is placed at 10 centimeter. It is telling that in front of mirror a object is with a distance of 10 centimeter. This is mirror and this is object. So this distance is how much? 10 centimeter. Okay. In front of it. Where is the image located? This is what we have to find. Okay. So you have to find where will image be located. So image we know that u is for observed distance, v is for image distance, h I naught is for height of image, and ho is for height of object. That's all things we already know. Question is saying find this where is the image located. We are not going to find the height of the image because question is not saying find the height of the image. It is saying where is the what is the distance, what will be distance to locate the image, okay, where object distance is placed 10 centimeter at a 10 centimeter in front of a concave mirror. So here remember according to distance, not according to height, according to distance we will take this. You know that there are two formulas to calculate magnification. M is equal to B upon U and M is equal to HI upon H naught. Sometimes you will be observing that here is a percent word minus, here is a percent minus. Yeah, minus. Now which one should we use from this formula? This question is arise. Which one should we select to find image distance? Of course, this according to distance. So m is nothing but minus b upon u. Clear? Now look at our brother. Magnified, which means magnification. So magnification is given, which is a 3 times. 3 times. Clear? Clear. And u is also given. U is also given, which is a minus 10 centimeter. U is a how much? Minus 10 centimeter. Points that are given, we have written over it. Now magnification is a 3 and V is a how much? We don't know. U is a minus 10. Minus 10. I think it will not come over here. It will not come over. So V is coming how much? Minus 30 centimeter. Minus 30 centimeter. This is what we have to find. So if object is over here, this is object at 10 centimeter. So here it is forming real image. This is forming real image. It's not in this. It's not. This image is not being formed inside the concave mirror. It is in front. This real image is in front of. It is in front of concave mirror here. So it will go where? I think here. Okay. I think here. So this is a 30 centimeter. 30, not a 33. Not a 30, brother. Yes, minus 30. What are you understanding? It is telling you that if 10 centimeter is a distance between an object and mirror, so you can see 30 is a 3 times of a 10. And Kishan was already saying that magnification is a 3. Magnification is a 3. And here you can see 30 is a 3 times of a 10. So our final answer is a 30 centimeter. Now it is telling that image distance from the concave mirror will be 30 centimeter, and it is in left side. This is in front of this is sign. Minus sign is indicating that image is in front of mirror. It is not inside the mirror. Clear? Yeah, I hope you have understood. Minus will come for something else. Now let me write next question. Let me write the next question. Now this is complete question. Try to understand. We don't have question. This is not based on it's not based on spherical mirror. It's based on spherical lenses. So remember, F will come out as a this is what is our answer. And length formula is what? 1 upon V minus 1 upon U is equal to 1 upon A. That's mean 1 upon F is equal to 1 upon B minus 1 upon U. Both are same. This is our length formula. Of course, mirror formula is what? Just we replace this minus with plus. It becomes a mirror formula. But here, as you can see, it's not a plus, it's a minus. That's why this is a length formula. Okay, length formula. So here, let's try to understand this question. What is it trying to tell? Did you get clarity? A convex lens. Which type of lens? Convex lens. I think it converts. Yeah. So a convex lens from a real and inverted image. You know that a real image will be inverted, virtual image will be erect. It's a nature, you can say. Okay. So a convex lens from a real forms, not from, forms a real. This type of lens forms a real image and inverted image of a needle. So we have object which name is needle. Okay. So this lens is forming this image of needle is inverted and it's a real. Means it's not this is not forming inside the lens. I think so. Yeah. So at a distance of 50 centimeter from it, concave. Okay. Where is the needle placed? Where is the needle placed in front of the convex lens? If the image is equal to the size of object. Now try to understand whether B is a given, but U is not given. That is what I am realizing. I am observing over here. Because it's saying where is the needle placed in front of. So also find the power of lens. Power of lens. So tell me, what will be U and V? So as you can see, we have 50 centimeter from it, so it's nothing but image. Now it is just saying where is the needle placed is a front of a convex lens if the image is equal to the size of object. It means whatever size of the object will be, so we will take same size for image. So here distance is given how much? 50. So remember this will be minus, it will be minus, and here it will be only 50. Okay, only 50. Okay, U came as a minus 50. Okay. Now, what is the f? According to Lenz's formula, we will get f. So f is nothing. 1 upon b. B is 50 minus this is also. I think it would become 50 plus 50. So 50, 1 plus 1, and this is nothing but 2f is equal to 50. So it is coming how much? 25. F is coming 25. I think 2a. Yes, it's a correct. And this is in centimeter. It's in centimeter. When we will convert this into meter, then it will become 0.25 meter. 0.25 meter. Now, if we brought the f, now we can use this for calculating power of length. So power of length will be 1 upon f. So 1 will be as it. F is how much? 0. So 25 upon 10. It will give you how much? You can see it is 100. So 25 fours are. So it is coming 4. 4 is coming. So power of length is 4. Killing 4. And this focal length is 0.25 meter. Here you can see 50 centimeter. U is minus 50 centimeter and V is also minus 50 centimeter. From this we got F, and F came as 0.25. From this we were able to find the power of length, and then we saw that P came as my plus 4. Okay, so here it is our final answer. Now let me write next question. Now it's our complete question. Try to understand, brother. Krishna is directly asking you what will be uh, power length where a focal length is given. This is what Krishna is asking for to you. So tell me, if a focal length is given and Krishna is asking what should be power length, will you be not will you be not able to calculate the power of length? I don't think so. Whatever points are given, you can write in your answer. So here F is given, which is 2 meter. It's in 2 meter. Remember, uh, power. So SI unit of power length will be what? Diameter. 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 So power of length is equal to 1 upon power of length is equal to 1 upon F. 1 upon F. Just a substitute value. So P F is a 2. It's in a meter, okay? It's in meter. Now you can say P is coming 0.5. It's coming 0.5. That. But brother, we don't have convex lens. We have concave lens. We have what? Concave lens. Concave lens. So that's why concave lens will give us a minus 2 meter. Okay, minus 2 meter. Minus 2 meter. But when we will have a convex lens, then we will be getting P with addition sign. So here we have concave lens. That's why you got minus P as a minus 0.5 factor, because of you have understood why did it come. Now let me write next question. Now whatever question will become will be very logic. Will be very logic. look at over here. Try to understand and get clarity. After getting clarity, tell me what are those points that are given by the equation. Here we have to find V as a now look at over here. An object which height is 5 centimeter. Okay, so here you can see h o is a 5 centimeter. This is the height of the object. Now it is held 25 centimeter away from a converging end. Converging which means convex lens. So distance between convex lens and the mirror is 25 centimeter. So u is nothing but 25 centimeter, and take arbitrator with the write this object distance with a negative sign, because it will be always object will be always in front of a mirror. That's why. So this is in distance. Object is in left side. In left side. So according to Cartesian plan, this Cartesian plan is giving negative sign. Okay, negative sign, because object is in left side from the origin. Okay, till here we are crystal clear. Of a focal length 10 centimeters. So focal length is nothing but 10 centimeters. Remember, here we have convex lens. If here was concave lens, so we take f as minus 10 centimeter, but we are taking it with addition, because addition is giving us a convex lens. That's it. So f is also given. Wow, but v is not given. Draw the ray diagram and find the position. This position, image, size, hi, and the nature of the image for. That's the same. So let's find first of all v. By the help of let's find v by the help of lens one. So 1 upon f is equal to 1 upon v minus 1 upon f. So f is given, which is a 10 centimeter. V is not given. U is also given, which is this much. So 1 upon 10, 1 upon 10. It's a plus. It will come in this. When we will shift this in this side, it will become this fraction will become negative. So 25 is equal to 1 upon v. Now we have fraction. So 25 comma 10. 2 5s are, so 5 5s are, 5 5s are 25, 25 2s are 50 I think. Yeah, 50. So 50, 10 5s are minus 52s are, okay, 1 upon v. Yeah, till here we are crystal clear. Now this is giving you 3 upon 50. Now tell me, what is happening over here, brother? So it is giving you v is equal to 50 upon 3, isn't it? When you will divide this 50 by 3, then what will happen? 3 ones are 3, then 1 0, 3 3s are 3 3s. So remember here, it's a 2. So in that case, 3 6 are 3 6 are to again 0.66. It will be continued. It's not a terminating. Uh, so our V is coming 16.66. V is coming 16.66 and it is a continued. This is a infinity after decimal. We got this V as a 16.66. It's nothing but this is a place of image. This is a place of image of a convex lens whose focal length is a 10 centimeter. Okay. Now, from this, what can we get next thing? So here, this point is clear. Now next size. According to size, you know that h I upon h naught is equal to m. Yeah. So here, I think so here HO is given. HO is given, which is a 5 centimeter. Which is a 5 centimeter. Now tell me, but H naught is not given and HI is not given, magnification is also not given. That's why we will not use this formula. Rather than use, you can use this formula. A is equal to B upon U. V upon U. So from this you will get a magnification. So V is nothing but it's a 16 point. So you can say 50 upon 3 multiply. U is a minus 25. Minus 25. Minus 25. 25 to the and here 2 upon minus 3. 2 upon minus 3. So I think magnification is 0.6. Can you say H1 upon H? Look at over here. This is the first formula, and next is what? V upon U is equal to M. So we can say this will be equal to this H1 upon H0 V upon U. Now here we want to get this H1. So H1 V upon U multiple H0. This is what it is happening. Now try to understand. V is given, U is also, we have a value of U and we also have a value of HO. Till here you can see how did it come. Now look, whatever you have values of this V, U, HO, you can substitute value. So H1 V is a 50 upon 3. Okay, and here HO is how much? 5, and U is a minus 25. Minus 25. Everything is fine. Now you can see here 5 5s are and 5 10s are. This minus will be as it. So it is nothing but, this is nothing but minus 3.33 in centimeter. It's our, here you can see this values, this value is in negative. It means our image is inverted. Our image is real because it is going downward the x-axis. That's all. So from this you can say image is real and inverted. Clear? Inverted. Two things are clear. Now, what is it telling you? So this is position of the image, and this is the image of the image, size of the image, and this is the nature of the image. Clear? Yeah, everything is clear. Now next question. Wrote this question. We have concave lens. Concave lens, which means concave lens. Yes. So middle part is thick, and edges of this concave lens is thick. This is what is the definition of a concave lens. So concave lens will look like that. This middle part is thin, and this edges, its edges is its edges are thick. It's our concave lens. The concave lens of a focal length is how much? 15 centimeter. Okay, so focal length is 15 centimeter. This is a 15 centimeter. an image an image 10 centimeter, 10 centimeter from the lens. So I think it is in front of, image is in front of, I am assuming that image is in front of a mirror, which distance is 10 centimeter in front of it. So here focal length is given, V is also given. But main point is what the sign should be applied. What sign? So here try to focus on lens. Which type of lens are you getting? So concave. So for concave, we take F as a negative. F as a negative. Clear? And B will be also negative. Why? Because we have concave. That's all. Focal length is 15 and image distance is 10 centimeter. 10 centimeter. But you can observe U is not given, which means object distance is not given. That is what we will find. First of all, we will find U. How far is the object placed from the lens? That's it. Only one thing we will have to find this, and then we can draw figure of this question. So question is asking only what should be distance of object in front of lens. In front of lens goes focal length is given is 15 centimeter and image distance is also given, which is 10 centimeter. In that case, tell me position of the object, distance of the object in front of a lens. So according to lens formula, we know that f is equal to 1 upon f is equal to 1 upon v minus 1 upon u. So f is given minus 15 is equal to then 1 upon minus 10. U is not given. Okay. Now try to understand here over here. When you will shift this in this side, then what will happen? Minus 15. This is minus, it will become positive. U, okay? No problem. Now 10, 15. 2 5s are 15. 3 5s are 10, 5. 5 3s are 15. 15 2s are 30. 30. Minus 1 upon u. So 15 2s are 30. 2. Okay. No problem. Can you say that it will become minus plus minus? Yes. So minus 10 3s are 30. Okay. It's giving you minus 1 upon 30 is equal to minus 1 upon u. Both will cut. So u is coming as a 30. But remember, here we have this plus and this minus. So my plus, it will become plus and now. U is coming as a 30 centimeter. 30 centimeter. So minus as it and plus as it. Okay, and here minus and this plus. Okay, now it's done. U is a minus 30 centimeter. This is our answer. Now let's draw figure. U is there, minus 30. So I think it should be over here. Object is over here. This is object. Okay. Now image distance is -10. It is also in front of this. This is an image. It's an image. So focal length is this. It's a focal length. F1. Uh, this is for you. I have told you something how to draw, and apart from this, whatever points can be applied, you will apply. Okay. So this is for you. We have brought object distance, which is a -30 centimeter. Just to draw this figure from this question. Shall we erase it? Let's erase. Let me write next question. Yeah, it's I think it would be our last question. V is this is our answer. We will have to bring this much, this. So let's see. An object is placed at a distance of 10 centimeter. Object distance is 10 centimeter. 10 centimeter. Now let's see what sign should be applied. So from a convex mirror, we have mirror, don't lens. Okay, we have mirror, don't not lens. So convex lens, it's a convex lens. Convex, which means outward surface is a reflecting surface. Outward surface is a reflecting surface. Okay. This inward would be coated area. Coated area. So convex mirror of a focal length. Focal length is also given, which is 15 centimeter. This is a 15 centimeter. So remember, we take U always in negative. In negative. Why? Because object is always formed object is always placed in front of mirror, and it's in left side from the origin. That's why. So this will be always negative. Clear? F is a 15. F is a 50. No, V is not given, brother. V is not given. Find the position and nature of the image. V and then nature of the image. So I think nature, we will be able to find nature by the help of a magnification. Uh, according to mirror formula, we can say according to mirror formula. So 1 upon f is equal to 1 upon v plus 1 upon u. 1 upon f. So here v is nothing, f is 50, and this is a minus 10. Okay, 1 upon 50, 1 upon 50, this will be shifted in this, then it will become positive. 1 upon 10 is equal to 1 upon b. Then 1 upon b. Now 15 comma 10. 2 5s are, 3 5s are, 5 1s are. Okay, so 5 3s are 15, 15 2s are 30. And the denominator, number is 30. 15 2s are, 2 will be as 3, 1 upon b, 5 upon 30, 5 upon 30, 1 upon b. So here 5 6 are, 1 upon 6 is equal to 1 upon b. At the end we are getting v is equal to 6 centimeter, 6 centimeter. What are you understanding by from this answer? You are understanding that image distance is a 6 centimeter, and it's not in front of mirror, it's inside the mirror, which means our image is virtual. If our image is virtual, it would be right. Now let's find magnification. What is the size of image? Is it diminished or magnified, enlarged, or equal? So we don't have height of the image. We don't have a height of the object. So we will use this minus v upon u, because value of v we have value of u. So minus will be as it, v is 6 and u is nothing but minus 10. So minus will cut to each other. 3 2s are and 5 2s are. So here 0.6, yes, it's a terminative. So m is coming out as a 0.6. What are you understanding by this? M came as a 0.6. Tell me, what are you observing? You know that it tells size of the image. So remember, if m is equal to 1, then whatever is the size of object will be equal to, for example, size of the image is size of the object is a 10 centimeter. So size of the image will be same 10 centimeter. This is what is the meaning of this m is equal to 1. What if m is greater than 1? M is greater than 1, which means m can be 1.1, 2.5, it can be 10, it can be 15. If this m is greater than 1, it means our image is enlarged. Our image is enlarged than object image. Okay. Now what if m is less than 1? Here 1 is greater than m. It means value of m can be, it would be less than 1. It can be 0.5, it can be -1, it can be -6 and negative. So here, which one are we getting in this? So we are getting this. Yes. So here m is less than 1. It means our image is size of the image is diminished. Not highly diminished, but it is diminished. Clear? So position of the image we have got, and let's see what are natures of the image. First of all, it's nothing but here what are you observing, brother? V is coming as a 6 centimeter. Virtual, erect, and the diminished. Clear? These are natures of image. So image format is virtual, erect and diminished. So finally we have answered. We got V as a 6 centimeter. It means image distance from the mirror is 6 centimeter, and we got m as a 0.6. From this we are able to tell that yes, our image is diminished, because this m is less than 1. That's why it is diminished. Now, how are we saying confidently that our image is a virtual and erect? Because we are saying confidently it because this V is a positive. This V is a positive, and it is in the right side. According to Cartesian plan, this is in a right side, and it is going inside the mirror. So inside the mirror will be what? Virtual. Yeah, virtual. All things are crystal clear.